This is a 2019 AP Calculus AB free response question number 4. This is the actual 2019 test. And this one is a good one to practice because it involves related rates, which is definitely a possibility for the 2020 test. This one involves a cylinder with height h, and the radius or the diameter is 2 feet, and that doesn't change. Okay, so the radius is always going to be 1 foot. And reading through the problem, it says a cylindrical barrel with diameter of 2 feet contains collected rainwater as shown in the figure above. Water drains out through a valve at the bottom of the barrel. The rate of change h, rate of change of the height h of the water in the barrel with respect to time is dH dt is minus 1/10 times root h. H is measured in feet, T is measured in seconds, and it gives you the volume of a cylinder with a radius r and height h is V is equal to pi r squared h. So part A says find the rate of change of volume. Okay, rate of change of volume in the barrel with respect to time when the height is 4 feet, and you got to indicate units. It's important to get the units right on all of these. Okay, so I rewrote the dH dt equation. I got rid of the radical and just called it h to the 1/2. That'll make it a little bit easier. And also we know that the volume is equal to pi r squared h, but since the radius is always 1, we can rewrite this as just volume is equal to pi h. Okay, part A, let's use our related rates procedure. What do we want? Well, read through it again, but what you'll see is that what we want is dV dt, the volume of water with respect to time. What do we know? We know that dH dt is equal to minus 1/10 h to the 1/2. All right, and it says specifically what is the rate of change of the volume of water with respect to time when the height is 4. So that's minus 1/10 times 4 to the 1/2. So that's minus 1/10 times 2, which would be minus 1/5. Usually in our related rates problems, it's where you're just given dH dt is equal to a number. This time they gave you a formula, and then they gave you the number, so you have to plug it in. So one more little step for that. And then we've got to relate what we want to what we know. So if volume is equal to pi h, and we want to differentiate that with respect to time, so we'd have dV dt is equal to, okay, what's the derivative of h? Well, that would be 1 times dH dt. Okay, so that's going to be pi times dH dt. Well, we know dH dt is negative 1/5, so it's going to be pi times negative 1/5, which is negative pi over 5. It makes sense that it's going to be negative because water's draining out, right? So the volume's going to get lower. And if you look at what's a volume, okay, a volume is a cubic distance. So the distance is feet, so cubic feet. And the time we're looking at, you just read through the problem. Let's see, T is measured in seconds, so cubic feet per second. Okay, so that's the calculus on that's really easy. The formula is easy and everything. You just gotta don't be surprised that you have to plug a number in to get the dt. Most of the problems we worked in the textbook, we would have given you dH dt is equal to negative 1/5. This time you had to plug in 4 to get that. All right, so that is part A. I don't think we need that part anymore. Okay, part B. says when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing. So the rate of change with the height of the water is dH dt. How do you figure out if that's increasing or decreasing? Well, you have to take the derivative of dH dt. So we need to find the second derivative. Okay, so if it's greater than 0, then it's going to be increasing. If the second derivative is less than 0, it's going to be decreasing. Okay, so let's see what the second derivative is. So we're taking the derivative of negative 1/10 h to the 1/2. So the second derivative is going to be equal to, okay, a half times negative 1/10. That'd be negative 120, negative 1 over 20, times h to the minus 1/2. All right, and then times dH dt. Remember, we're taking the derivative with respect to t, so we have to have the dH dt in there. Okay, so we know that now we're just going to simply plug the numbers in here. So that's going to be negative 1 over 20 times, okay, h is negative 1/2, so that's going to be 1 over root 3. And then times negative 1/10, so we're using dH dt now, times the square root of 3. Where did I get 3? That's in the problem, 3 feet. Okay, so the square root of 3's will cancel. Negative negative would make positive, so that's going to be 1 over 200. Okay, so that is greater than 0. So since it's greater than 0, it's increasing. So you do have to justify your answer. Okay, so don't just plug 3 into this. Again, to get whether something's increasing or decreasing, we have to take the derivative. And so we're taking a derivative of a derivative, so ultimately it's just a second derivative there. All right, so that's part B, not too bad. Numbers are a little tough to deal with, but now part C is a very famous problem. I just would be shocked if you don't get one of these on the 2020 test. So it says, at time t equals 0 seconds, the height is 5 feet. Use separation of variables to find an expression for h. Okay, so this is the classic problem. Okay, we've got to separate the variables, all right, to get an expression for h. So we're going to separate this. And what I'm going to do is bring the h to the 1/2 underneath the h. Okay, we'll just go ahead and call that root h if you want. I'm not going to move the negative 1/10 over. That just makes things harder. Let's leave it over there. So leave it on the right, because it's really easy to integrate dt, right? So we're just going to end up with a negative 1/10 t there. Okay, so that's the same as h to the minus 1/2 dh. And then integrating dt would just be t. So this would be add 1/2, add 1 to the exponent, so 1/2. We need a 2 out front, right? 2h to the 1/2 is equal to negative 1/10 t plus c. Our point of interest is when t is 0. Okay, so we've got 0 and h is 5. So we'll plug in, that's going to be 2. Root 5 is equal to 0 there, so that's c. So we would have 2 root h, so I'm plugging in c, is equal to negative 1/10 t plus 2 root 5. Okay, so I just brought all this down here. Okay, let's get this, this 2, divide both sides by 2, and just make it root h is equal to negative 1/20th t plus root 5, so the 2 goes away. Now, how would I get this to just be h of t? I'm going to square both sides. This is one of those problems where each step would be like worth a point. Okay, so this is going to be negative 1/20th t plus root 5 all squared. And so you are done with that one. So I don't think that one was too bad. That's a good problem. It gets you both practice in related rates. It gets practice in taking a second derivative and telling you whether it's increasing or decreasing, and it gets you practice in separation of variables. So what a great problem. You could see all 3 of those things on the 2020 test. So I'm going to let that be it for this video, and we will see you on one of the next ones on the 2019 test.